let's start with the lecture today. So we are going to do the macro definitions. How do you define a macro? So yesterday we had a look at some examples with we had a look at when. So and or not also I mentioned it, and I think it's quite straightforward. Like there's nothing much to talk about that. But it's just less than 1, 3. Okay. It's just this thing. I mean, it's just standard thing construct, but you'll be doing it in Lisp in this format. So this gives you true. Okay, and of course, see the empty list is false. Okay, so if you have it, then you will get it as this. Okay, and I think it's a shortcut form also, because this can be arbitrary expressions, right? Is this could be basically yeah, it could be arbitrary forms. For example, let that's the difference actually. X1 and Y2. So this is closed here. Now I'm saying greater than XY. Okay, format it first. Okay, then I'll put this in and we'll close it. And what's happened? That's all right. So you can have side effects actually. Why did it not close? Okay, it's a let. Yeah, I didn't close the let. Sorry, I had to close the let, and then you do the close that. Okay, so this is one thing here. So what I wanted to show is that basically you can say let, okay, and then do this thing format t second form. This will not be reached because it is a shortcut short circuiting. It's called short circuiting, right? And is a short circuiting and. So yeah, this is the kind of thing you will get. You will not get. It is clear, right? I hope it's clear. So this is like standard stuff. This is the first form, and that's the second form. Second form is not reachable because this nil it's a short circuiting and. The moment it hits false, it will just basically it will remove that thing. I mean, it will just it will stop there. It's a short circuit. Okay. Now, why is this not this thing? This should be greater than xy. This is false. Okay, so less than xy. Okay, that's the key thing you need to understand in and percentage. And similarly, OR is also short circuiting because you will see that if you do OR, you will get only the first form. The moment it returns true, it returns it. But so it only does the minimal amount of thing to to the first. Basically, OR what it does is it takes the first true form, first form that returns true, and once it returns true, it will stop. So this is false, so it has to do the second one, and it does the second one, and it does through thing. So if I have a thing like this, then it's a nil. So basically, or both are short circuiting. I think you're clear on that, right? So and then I can put a not in both of these things. You can put a not thing. Not is a function, whereas or and are macros. Okay. So I hope that's clear. So we have like yeah. So the key difference is that from other languages is or and will be taking like you would basically write them as Boolean conditions. Usually the expressions are less than, greater than, and so on. But notice that even there you could write functions. If functions return something, you would write and of a function name, a function call, which would then do some arbitrary computation and do that. But usually it's not the case. People don't use it that way. But here it's more you can use the OR format as inside that OR you could have function forms. So all of these, or by intrinsically it takes in a form. So it's very natural to have this type of programming. So yeah, you can mix it like this. So this is much more, it's like, yeah, you have a condition and you also do inside the condition check, you're actually doing some computations. No side effects, everything you can do it like. As I said again, this shows you how flexible the language is, right? And I mean, it doesn't constrain you in any way. Inside a Boolean condition, you're actually doing a Lisp form. And if you have programming, if somewhere you want to do some check for something, you can actually write it down like this. So that's quite, powerful, this feature. So this is with the macros, okay. So we had a look at some of the macros last class, control structures like when, unless, all right, unless, and now we had a look at or and, all right. So let me just check that. Yeah, let me close this. It's clear, right? I hope I'm making sense here. Any doubts so far? So let's move on to today's class. Today's class is basically how do you define a macro? Okay, these are all inbuilt macros that come with this. So how do you actually define a macro? Okay. So yesterday I had showed you this is the definition. Alright, this is an example definition. Let's just run it and see how it works. Because so we can, I mean, before in order to discuss it, let's just take out a sample thing. Let's have these two defined. Okay. All right. So prime number P is basically prime P. So as the definition says, all right, and then you have next prime number. So we have these things. So loop will come back to this thing, but you could have written it as another construct. Basically, what you're doing is, yeah. So let's go through the. So basically, what it's doing is macro. So these are all inbuilt definitions. We had a look at it. Do list, do times, and for. Now along those lines, we are actually going to create a function called do prime, do primes. Okay, and let's just go from the reverse point. I think, right? So what I want to do is I want to write something like do. Let me take down this definition. So this is the definition. So I'm having a definition. Don't we'll come to the definition later on. But what does it do is basically how do I use it? Okay. What does it give me? Okay. Like I showed you and an or. Alright, it gives you some kind of it gives you some convenient way of writing your programs, and at the same time doing a Boolean condition check. So those and or are macros, whereas not is basically a function. Okay. Now format T, I can say format. I just print out that thing. So how do you actually create a something like this? All right, and let's see what is it to. So what we are creating is instead of iterating over, let's say we had do times, right? Do times I and 10 format T in the D and I. So we did this. It's not do times, I think it's R5. Yes, I think this do times. Yeah. This is the format. Okay. I mean, this is one thing we had to look at. We also had to look at do list X, and you can give a list here 1, 2, 3, or let's just put in 5, 7, 9, 11. Okay, and X. So basically, it iterates over the list. This iterates from 0 to 10, less than 10. Okay, the moment it hits 10, it will basically break out. This is another way of doing it. Now what I wanted to do in the same along the same lines, I am defining something like this. So if you have any doubt, you can ask, let me know. But basically, this is the, so along those lines, I am going to define my own primes. I can actually define my own macro. What it helps you to do is it actually allows you to define your own control structure. And among many things, you can do other things also. But let's say you wanted to do something like this, you can actually do it. Okay. This is what macros allows you to do. It gives you that much of flexibility. It gives you that much of power that you can actually define your own construct. So you can rewrite things as that. It takes the loop itself. You can redefine it. You can redefine the way you want the loop to behave. So we had a look at do list 2 times, and now we're doing do primes. This is the objective. So it's easier to look at it from the end objective, what you are trying to do. Okay. So for that, so this is the definition. Okay. This is one way of defining it. Yeah, so let's go to the slide and have a look at it. So let's read through this. Okay, what is it saying is that you give me a var and range. So as I told you before, I have it in this thing. Yeah, so def macro name, parameters. Then we can have, if you want, you can have a documentation string, which is not present here. We could actually define it. All right. Let's say here there's a place where you can define the macro string, documentation string, saying loop or so we can actually do this. Okay. So what is this thing doing here? This var and range is the list that you're providing. Let's go back to this. This is the list. Okay. So the parameters that the macro takes, there are two parameters. The first one is the var and range, whatever the structure of that thing is. I mean, this is the one parameter, and the rest, see the rest thing, it's a body. Okay. Body could be anything. It could be a basically what we wanted to do is the rest. What we have decided is that is actually a list forms, list of forms. Okay. So that's what we have it here, and see that the rest parameter is coming to picture here. Okay, so those whatever comes after var and range, the first thing that will be is a list, which will be of this form, and then whatever follows that are the instructions that should be iterated over. So here I gave you an example where it's just a format T, but as you can expect, you can also have another type of. I mean, you can have other instructions. This is one list form. All right, and then I can say something like, let's say, yeah, what can I put in here? Yeah, what can I do? Yeah, let greater than, let's do an or. Okay, or no, or not let's say put in, so just something like p 15 when, let's use when greater than p, let's say something like 1, let's say, let's break it at around 100. Okay, let's just do a format T and let's put it in a new line. Okay, this is one then I can put in another thing like saying when greater than p 1000, let's not go to 1000, let's put it as 200. This is what we have here. So the thing that I wanted to show is that you can have arbitrary this thing constructs here. All right. So you can have this is the list. This is the rest parameter. The rest parameter, which is a body. body of list form. So it could be a number of arguments. Each of those arguments we expect it to be a list form. This is what we have in our mind. Okay. So if I go like let's say 119, it will basically do it this way. Okay. So what is happening here is after it's greater than 100, it's actually printing a thing. So this is the yeah, this is the structure actually. So that's how we. So basically, what I wanted to show is you can have like arbitrary this thing. Let's just format it like p equal to let's make it equal to 103. All right. So this is the structure you get. Okay. Hope this is clear now. Yeah. So you can do kind of like a lot of things here. Let's put it as 250. We start getting this type of thing. Yeah. So I hope this should be clear enough. So let's go back to what we. Let's just do this thing off. So what I wanted to show is that you can have, so let's go back to our original thing. So we saw that we can have var and range. This is the structure we have decided ourselves, that our input will be like a list first, which will be of the form P0 whatever number. And this thing can also be you can actually plug in a number also. Yeah. So we can have a look at it. But basically we are plugging in some value, all right? And we are trying to work with it, okay? So when we do that, we get this type of, we can actually take the body as, so notice that we are treating this as a function because we have defined it, but it's actually not a function, it's a macro. So it gets expanded in compile time, all right? So before the evaluator even comes into picture, the macro will get expanded, it will be rewritten, okay? It will be rewritten into something which the underlying Lisp actually can evaluate, okay? So we are building on top of the existing language, redefining things. So you can see that a control structure is something very essential to a programming language, but we are able to redefine our control. We are able to create our own control structure, okay? For that, it is done. It's done as a macro. We are using a macro definition form to do it, and the macro basically behaves just like a function, but the only difference is that you can, you're providing you're providing your own structure, okay? So how you want to go about it. So these are your commands, and this is your argument, okay? This is your do primes definition. Any doubts so far? So how the question now is, how does it do it, okay? How do you go about defining it? So var and range is, so we decided our structure format, like how we want our thing to look like. So this is the rest of the body. So what do is we take out the first var and range, okay? In this definition, what we are doing is we are taking out that variable p. That is my variable. Start is the second element of the list. This is the start, and end is the third element of the list. All right. And then we are doing we're putting into a do, okay? So this do we'll have to, so we are converting into a do, and the do is a macro that is defined in Lisp. All right, this is we are converting our definition into something much more simpler, which is the do, which is the part, which is another macro which was written by, this is part of our implementation. Most common Lisp implementation have this. All right, and the body is then plugged in here, okay? So notice that this backquote is different. Let's see if this is equal. This is a backquote though, and this is the quote. It's true. And like this, if we see, it's also true. So this, but you have to notice that we are using a backquote, not a single quote. Okay. So backquote. Let's see if we can see some difference here. So we are able to deliver that, and So we notice that in the macro we cannot use a single quote. We'll have to use a back quote. So we'll go more in depth into that in the next lecture. But that is the comparing with the function definition, you notice that we need to convert it into some other construct that is inbuilt in our list. So this is the way we go about doing it. We put in a let form, which we know how it works like, and then we put in a back quote, right? And then so the back quote actually just plugs in the definition. For now, we can just think of it that way, right? And in order to unquote something, a back quote allows you to so this back quote actually allows you to have this quote thing. It allows you to unquote something within the list. All right. For example, fx, let's say 500. Okay. If I do, I guess this will be possible here. Yeah. So if I want to unquote, I use this. Get it? But I guess this is not possible in single quote, right? This is the difference. So back quote versus single quote should be clear for you guys now. Because what I wanted to do is I want to evaluate on variable. I want to unquote something. So I can use quote comma x inside the back quote, all right, and it will evaluate that thing will get evaluated. The variable get evaluated, and you can also use at the rate of body. That is for a list, I guess. Okay. So these are the two things that you can do within a back quote. Whereas in a single quote, you cannot have a unquoting. See, comma is illegal outside of back quote. So I hope that you also understood why we cannot. This also relates to what we did in the symbols class. Okay, back quote and colon was comma was not there. This is where a comma is used. All right. So what happens here is this where has been set. Okay, in your let form and start and end. So you are saying that you convert it into a do form where the thing is going to be like this. Okay. So this variable will be evaluated in the back quote, and similarly this variable and this end will be evaluated, and then you have the comma at the rate of body. So body is the input body that you gave into the thing, where and range was this. So this can actually be simplified even without going into the actual definition. We can actually simplify it to this. All right. So this is the second example he gives in the book. Okay. So what are you doing here in the Mac? You're using destructuring. What I don't let me just look at the exact word that is used. Uses some particular terminology for that. So defining your own. Destructuring parameter list. There's something called destructuring parameter list. All right. Macro parameter lists are what are called destructuring parameter list. All right. So we don't have to. We can first of all, what we have done is we are telling not just that it's a var and range as we were doing before. It's not given to you as input, but you're destructuring it. So this is some place where you can destructure it. Inside a macro, you can actually say that my input will be of the form var start end. So it is very clear what the thing is. And instead of rest, I can say ampersand body, which you can think of it as basically ampersand rest, but it gives more information to the compiler that it's actually a body form. Okay. So it's a particular type of rest thing. So and then you give body, and then similarly the rest of the thing becomes very simple. So you don't have to do let now. So this itself, the macro itself is taking care of the variable destructuring. So here you have to destructure it, right? So we don't need to do that. Okay, this makes things life is easier. This destructuring parameter list makes the definition much more compact. All right, and then again we go back to the back quotes. We can put in a var, and then we can plug in the variables. We are using the variable from here. So we are saying that var next prime start. Now the thing is do we did not cover. Okay, so do we'll just do this. In order to understand this better, we have to go through the do thing. What does a do? Okay, because this macro you are basically converting into 3 lines of involving a do loop. Okay, so in fact, if we want to test thing, see, this is the do loop. It's one do loop. Okay, so one do loop is being a thing, and do is also another macro. All right. So this definition again, if we use our this thing for doing our earlier example. So again, notice that this is the macro definition. Okay, you're defining a macro like this, and this is a macro application. You're applying your macro to get your result. All right. So if you want to reduce this, what did I do? On 99. Okay. And in fact, let's use a new one. Okay, which is basically so I hope that this part is clear. Okay, going from here to here, notice that what in order to define a macro, the only thing you need to understand is this backcode, and that you can actually, inside a backcode you can use the variables. All right, if you want to evaluate a variable within a backcode, so you use this comma where. All right, and this is a list. So let me just give you another next example. Okay, let's say def set f star list. So you can use in here, you can use a quote or this thing when you're defining data. All right, you can use single quote. You can also use a double back quote. You can say like something like this: 1357 and 13. All right, you can use either quote, but the value of a back quote is that you can actually use it to escape escape something like this. Okay, to escape variables, and you can use comma at the rate of list b. Okay, and say 5. Right, this actually destructures it. Right, if I had to use this, this doesn't do anything. Okay, but if I do this, yeah, so you get the point, right? This is the definition. These are the differences you are using to make your work easier. To make your life easier, you're doing this stuff. Backquotes helps you to escape. Instead of backquote, you can actually escape a variable, and you can also that variable could be a single value like 500. It could be a list also. As is, it will be plugged in. But if you want to destructure that list, you do comma at the rate of. So it'll remove that first outermost parenthesis, and it will treat it as an array, and it will plug in that array after it has destructured it. It will plug in the elements of the array as is. Okay, which is what we want in the this thing. In this part, this is what we want. Okay, so let's have a look at the do form now. So everything is clear, right? So this in this definition, so I'm going from in this manner, in the sense that this is a function application. Okay, this is the application, but the definition of a macro, so it's a function macro application. I'm using the macro, but this is the definition of a macro. This is my definition, which uses it in this form. So the only thing pending here is, so we understood how the backcodes work, how it escapes variables, and what is the relevance for escaping. How do you destructure and plug in the this thing? Okay, it's actually removing the elements. It's taking the elements of the list, which a body form is basically, because rest of body will collect all of this as a single list. Okay, if you have done the rest exercise, if you have used a rest parameter, you would have seen that it collects all of the remaining elements into one list. So what we are doing here is we are removing that one level of aggregation, and we are bringing in all the elements and we are plugging them one by one after another, which is what we want in the in our definition. Okay, so the only thing pending is to understand how the do works. Okay, so let's have a look at what do macro does. So we had a look at do list and do times. Previously we had a look at do list and do times. So just to refresh, do list gives you x. Okay, I'm using a backquote here, and then format t I think we just did it just now, right? Okay, but let's do it again. For refresh, to refresh, this is like this. Now if I say something like 1 5, it will basically, okay, sorry. So let's do the do list and do times. I mean, let's understand the do first. Okay, and do times. All right. Now we have a more generic construction called do a more general construct, more general control structure that Lisp provides, which is called a do. Okay, a do variable form. So it's much more general in the sense that do list and do times actually convert into do macro internally. All right, and do is also a macro. Okay, but it's much more general definition. And the way you do it is like you have to give variable definition star, and you have to give an end test form and a result form star. Okay, so you notice that this is a result form star, but we will have only one result form. Okay, mostly we will look at only one result form right now. We will look at this. I mean, this is discussed in the book later on, so we don't want to think about it. Just think about it as a either it's going to be there, it's going to be one form, or there's going to be no form. All right, which is the result of the whole do. Okay, notice that if you go back here, see the result was nil. It's always going to be nil for do list and do times. But do you can actually return an expression. At the end of the loop, you will evaluate this form and you will return the result. If there is nothing, it's nil basically. It goes by like do times and do list, and then you have a list of statements. Okay. So I hope you understand that. Notice that this is also a macro. Okay. So not only we can also define our own macros. Lisp also is providing you macros by definition. So the core language is very minimal in Lisp, in common Lisp, all right? And that is where the standards come into picture. All of those have to follow the common Lisp standard, okay? But then on top of that, the implementation might differ a lot. This is why you have, like dialects. Dialects are very prevalent in Lisp because of this macro feature. One of the reasons is because of this macro thing, where you can have your own definitions on top of this. And the implementations provide you the definitions, and depending on the implementation, you make use of the implementation to write your programs. Okay, but if you want it to be portable across implementations, you would not use those implementation specific features. But do is, I think, prevalent. It might be a part of the standard also. We'll have to see that. But right now, this is how it is. So you can see that it's like quite. It is implemented as a macro. Okay. So let's see this definition. So it's where init form, step form, like let, just like let you had this thing, right? So let me see if there is an example here. Yeah. So in the let, what happened? We had a variable definition star, but unlike let, the difference between this and let is that this is of the form. It will give you an initial form. It also has a step form. So the init form is evaluated. Both are forms, by the way. Just like let. Let also you could have a form, but it would be a variable and then an initial form only. You don't have a second part. But here you can have a init form, step form. Okay. Step form is evaluated before each iteration, and the result is assigned to variable. All right. This is the result of. Short. This is the structure of a do macro. And you have an end test form. This thing tests. If the end test form is returns true, then it will basically quit the loop. And result form basically gives the result of it evaluates this at the end of each iteration. Okay. And what does it iterate over? It iterates over these statements. Whatever statements you provide, it will iterate over those statements and it will do those forms. It will evaluate those forms one by one, and it will do it for each of for the iteration. Variable definition obviously is initialized in the initial thing before it starts the loop. After that, it does the step form. So it will do the step form at the end of each iteration. It will evaluate the end test form, and it will see if this end test form is true or not. If it is true, it will execute the statements again. So this is the basic thing about do macros.